And now let's sketch this hyperbola over here, and we're gonna first determine the center of the hyperbola, the center point. So we have x squared, right? So that will tell us that our x coordinate will be 0, because we don't have something like x minus a number, right? So just x squared, 0 is the coordinate for x. And the y coordinate will be just 2, because we have y minus 2, so we reverse the signal. So 0 and 2, that is the center and our starting point. Great. So now we're going to take the 16 and make it 4 squared. We're going to take the 25 and make it 5 squared. And we're going to go 4 units up and down because of that 4. Why up and down? Because the 16 is underneath the y term. And we're going to go 5 units right and left because the 25 is underneath the x squared. So we move horizontally. There we go. Now we're going to make a nice little rectangle. That was not a rectangle, that was a line. So let me fix that. Hitting all those points. Great. Now we can draw the asymptotes of the hyperbola. And the asymptotes will pass through the edges of the rectangle diagonally. So let's do that. And our slope is just 4 over 5 because we go 5 units to the right and 4 units up. I believe it's right here. Yeah, that looks good. Or at least it doesn't look terrible. And same thing over here. So those are our 2 asymptotes. Now, which way does the hyperbola go? Up and down or left or right? If you answered left or right, that'll be incorrect. If you answered up and down, you'd be correct, because the y term is positive. Great. So the vertices are right here, here and there. Nice. So now we can draw our curves. I'll try to do a good job here with my software, even though it doesn't cooperate all the time. Yeah, that was not too bad. And it's the same thing up here. So note, of course, that the hyperbola runs very close to its asymptotes, but it never actually touches them. So it goes very, very close. Here it looks like it's touching, but it's supposed to just go very near it. And that's it. So the red curves represent this hyperbola, and right now we're done.